Lord, our Lord, how majestic is your name in all the earth. You have set your glory above the heavens. Out of the mouth of babies and infants you have established strength because of your foes, to still the enemy and the avenger. When I look at your heavens, the work of your fingers, the moon and the stars which you have set in place, what is man that you are mindful of him, and the Son of Man that you care for him? Yet you have made him a little lower than the heavenly beings and crowned him with glory and honor. You have given him dominion over the work of your hands. You have put all things under his feet, all sheep and oxen, and also the beasts of the field, the birds of the heaven, the fish of the sea, whatever passes along the paths of the sea. O Lord, our Lord, how majestic is your name in all the earth. May I lead you in prayer. Our Father in heaven, we can echo these words.
Well, thank you very much. Thank you, John. And I wonder if shortly those can start around shortly. Thanks a whole lot for coming this evening, all of you. I'm blessed and privileged to have you here. I consider it a very serious stewardship of your time. For me to steward your time and to steward your minds. I hope to do you well this evening. And I would appreciate your prayers throughout that I would do exactly that. Let me begin by just telling you why I'm involved in this. I mean, I'm principally a theologian and church historian and economist, actually. No degree in theology, but I've taught systematic theology at the seminary level because of all the other studies that I did. Do have a master's in economic ethics and a PhD in history, particularly a bit of church history. But why would somebody with that sort of a background really care about this kind of a subject? And why would he particularly care about it so much that he's been studying it for right about 28 years now and has, over the last 12 years, dedicated a huge portion of his life to it. The last 10 years, it's been essentially full-time, so that he's read over 50 books and many thousands of articles on the science of climate change, and over 30 books and many thousands of articles on the economics and even the engineering of climate and energy policy. Why would a theologian do that sort of thing? And the answer actually starts out in my very early childhood. I won't trace my whole life from there because we'd never get to the subject. But it does trace to that, and here's how. When I was a little child, my father worked with the U.S. State Department, and he was posted to Calcutta, India. And shortly after we arrived there, my mother contracted a virus that attacked her spinal cord, and she was paralyzed. Because of that, I was farmed out to an Indian family each day that took care of me through the day. So early each morning, my ayah, or nurse, would arrive at our apartment and take me by the hand to my family, where I would stay the day. Along the way, we would go through the courtyard of our apartment building. And there I saw every day a huge, beautiful green tree. Think in terms of tropical sorts of trees, or subtropical. Calcutta is in a subtropical region. And hanging from that tree, there was a beautiful vine with large, gorgeous red blossoms. And I remember, as a very little boy, seeing that every morning, and the pictures of that, the beauty of it, became a permanent part of my childhood memories. I have those pictures in my mind, indelibly printed there. Now, long after that, when I became a Christian and when I began studying the Scriptures, I found that the Scriptures have so much to say about how the creation itself displays the glory of the Creator. And they have a great deal to say about our responsibility as God's children to take good care of His creation and, in fact, to enhance its fruitfulness and its beauty and its safety. After going through the courtyard, we walked out onto the street, and we would walk the several blocks to where I was taken care of for the day. And my other very powerful set of picture memories from my youth is of the bodies over which I stepped every morning, of the people who had died overnight of starvation and disease because of the extreme poverty of Calcutta in the 1950s. Probably stepped over thousands during the time that I did this, more than most morticians deal with in a lifetime. Those memories also are very powerful to me, still pictures in my mind. And they spoke to me of the horrors of poverty. And when I became a Christian and studied the Scriptures, I learned how much the Bible has to say about poverty, about the responsibility of God's people to care for the poor, to protect them against oppression, to remove obstacles to their rising and staying out of poverty. And when eventually, through my studies, I came to confront much of the environmental movement and saw that a great deal of its policies really had consequences that were harmful to the world's poor rather than helpful, I realized that as a Christian, with my background, with my understanding of the scriptures and so on, God was calling me in my life to devote a great deal of my own work to serving, to protect the poor from the negative consequences of a lot of environmental policy. One of the areas in which that is most pronounced is the area of climate change and what we are being urged to do to minimize, to mitigate global warming caused by human activity. So I'm going to talk with you tonight about that. I wish that I could also spend a great deal of time talking to you about other environmental issues as well, but frankly we don't have that kind of time. But I do want to make sure that you understand that while I'm going to be speaking negatively about one aspect of environmentalism tonight, the principle that we as God's creatures, and especially as God's redeemed, have a responsibility to use His creation in a way that is not abusive, that is not exploitative, but rather that is caring, that is wise, and that, as I mentioned a moment ago, enhances its fruitfulness, its beauty, and its safety to the glory of God and the benefit of our neighbors. This is how I describe godly dominion, picking up on the language of Genesis 1:28, where having created Adam and Eve after His own image, God blessed them and He said to them, "Be fruitful and multiply and fill the earth and subdue it and have dominion over the fish of the sea and the birds of the air and everything that moves on the face of the earth." Some people in the environmental movement think that Christianity, because of its belief in Genesis 1:28, thinks that it's fine for us to just abuse the earth, because after all, it's all going to burn up in the end anyway. Now, you can go through the whole history of Christian commentary, and even before that, rabbinic commentary on Genesis 1:28, and never find any commentators interpreting it that way. So the charge is entirely a caricature, but nonetheless, that does arise. And every once in a while, I've met Christians who have thought that charge was actually deserved. What they aren't aware of is that the best record historically in taking good care of the environment has happened in those societies that have been most shaped by the Christian faith. Nonetheless, there are those who think that human activity, particularly the use of fossil fuels to generate energy for electricity for all of our lights and our motors and our refrigerators, our air conditioners, the factories where so many of our goods are made and so on, and to generate vehicle transportation through gasoline and diesel and things of that nature. They think that our use of this is adding CO2, which is a greenhouse gas, an infrared absorbing gas, and therefore will actually make the Earth's atmosphere warmer than it otherwise would be. They think that we are causing a potentially very dangerous global warming. So that's what I want to speak to you about tonight. But, you know, I always want to approach issues like this as an economist with a question in my mind: what are the benefits and costs of the activity that we're already doing but are being asked to change, to reduce, or to eliminate? And what are the benefits and costs of the activity that we're being asked to embrace instead, to increase, or to use an entire replacement of the previous activity? Because I think it's important to think in terms of cost-benefit. A biblical verse that addresses that is Proverbs 14:4, which says, "Where no oxen are, the manger is clean." That is, where you don't have oxen, you don't have manure, right? Manure is a problem. But in the strength of an ox, there is much gain. And that verse really embodies the principle of benefit-cost analysis, or cost-benefit analysis. If you have oxen, you got messy mangers. But you also have the strength to pull a plow in order to be able to plant seed better and get a better harvest. And so you have a trade-off there. You accept that there are some costs to this activity and there are some benefits to this activity. And basically, in a primitive agricultural system, you recognize that the benefit of an ox far outweighed the cost of an ox. Nowadays, though, you might not think that because we don't use oxen, we use tractors and combines and things of that nature. They have their costs, but they also have their benefits, right? So I apply that same principle to this issue of climate change and what we ought or ought not to do about it. Now, the basic thesis of those who are raising the alarm is that as we burn fossil fuels to create this energy that is absolutely indispensable to lifting and keeping any whole society out of poverty, we're emitting so much carbon dioxide into the atmosphere that we're causing dangerously rapid, high magnitude warming of the atmosphere that will have all sorts of catastrophic effects on ecosystems, on sea level, and on human well-being. And therefore, we need to reduce our use of the fossil fuels to reduce our CO2 emissions, to reduce the global warming. So that's what I want to talk about a bit tonight. Now, as I'm talking, I would like to invite all of you to subscribe to the Cornwall Alliance's email newsletter. It's totally free, comes out once or twice a week. As a matter of fact, there are a couple of people here, Fred Rumack and Mary Snyder, who receive our newsletter. They might testify to the value of it. It's always educational. And I will tell you, if you decide you don't want to keep getting it, every single issue has an unsubscribe button, so you're not stuck with it. We won't just keep filling your inbox if you don't want it. But it's an educational newsletter, and it will lead you to a lot more information than I can possibly give you tonight. So John is going to start around a couple of pads of paper, and if you'd like to subscribe, all we need is your name and your email address on there, and we'll take care of actually subscribing you. If you turn down this opportunity and you later decide you want to do it, go to cornwallalliance.org. That's cornwallalliance.org, you see down there, and you can sign up quickly online. So, first I want to ask, what are the benefits of using fossil fuels? And then we'll look at the alleged costs of using fossil fuels and at the alleged benefit of reducing our use of fossil fuels. Now, I'm going to talk first very, very briefly about the most direct and obvious benefits of fossil fuels. They provide 87% of all the energy used around the world right now. All of it, right? 87%. Another 7% comes from nuclear and another 4% from hydro. That leaves about 2%, of which estimates vary as to how much comes from wind and solar versus how much comes from a variety of other renewable energy sources. But at any rate, those renewables altogether constitute about 2% of all energy consumed in the world today. Now, since energy is what we use to do all work, and work is what produces food, clothing, shelter, health care, transportation, communication, factories that turn out all sorts of neat things like cars and trucks and computers and everything else. Since work is what produces all of the various goods and services that enhance our lives, that make us healthier, that make us live longer, that energy clearly serves a very good purpose for us. And it enables us to be wealthier and healthier and longer-lived than we otherwise would be. But there's, and I will return to that issue a little later in the talk, but there's another benefit of using fossil fuels that most people don't think about. And that is the very thing that the folks who are alarmed about dangerous global warming point to as the culprit in all of this. It is the demon. It is carbon dioxide. Some of these folks are so fearful of it that they embrace some ideas that are really quite amazing. About 3 weeks ago, The Nation magazine, which is a pretty left-wing magazine in the United States, been around for many decades, ran an article by a University of Michigan history professor that said that carbon dioxide is a, quote, far more deadly gas, unquote, than the nerve gas, sarin, that Syrian President Bashar al-Assad used to gas a bunch of his citizens earlier this year. Well, do you have any idea what a lethal dose of sarin is? It's about 0.5 milligram. 0.5 milligram, right? Now, the average human being exhales slightly over 1 kilogram of CO2 every day, which is over 1 million times 0.5 milligram. If CO2 were far more deadly than sarin gas, then the human race should have gone extinct the first time the first human took a breath. It's amazing the incredibly stupid, uninformed things that get published and not challenged. Now, I did challenge it with an article that was published in another publication, but as far as I know, nobody has challenged that in The Nation. It's an amazing thing to think about the fact that this magazine has editors and presumably fact checkers, and nobody caught that in that article. That's one example of the kind of scientific nonsense that gets published in purportedly reputable sources. Well, what about CO2? What do we get from CO2? Well, first of all, by the way, carbon dioxide is an odorless, colorless gas that is non-toxic to human beings in concentrations less than about 30,000 parts per million, and then only if you're exposed to it for about 15 minutes or more. You can do just fine in 5,000 parts per million for many hours at a time. In the United States, the legal standard for the workplace is that you can't go above, I think it's about 4,000 parts per million as the average over a 40-hour work week. So, I mean, that's a lot. The natural background rate of CO2 in the atmosphere right now is about 400 parts per million. So we could go to 10 times that and people would be fine, right? So it's not a toxic gas except at very high concentrations. By the way, every breath that you exhale has about 40,000 parts per million CO2, right? So this is not something that is typically toxic. But what about the benefits of CO2? As you all, I'm sure, learned in grade school, plants take in CO2 in order to do photosynthesis to build the fiber in their beings, okay? That's how plants grow. And the more CO2 they get, the better they grow. And we can summarize the function this way. For every doubling of CO2 concentration in the atmosphere, you get an average 35% increase in plant growth efficiency. Plants grow better in warmer and cooler temperatures and in wetter and drier soils. They make better use of soil nutrients, and they resist diseases and pests better. Consequently, they expand their ranges, which means that all the insects and animals that depend on them can also expand their ranges, which reduces the risk of extinction for any of those. That's a pretty cool thing. If I were an environmentalist worried about species extinction, I'd be clapping my hands about more CO2 in the atmosphere. But there's another thing that they do. They increase the yield of fruit or grain from the plants. And one major study released in 2013 by my friend Dr. Craig Idso of the Center for the Study of Carbon Dioxide and Global Change, reviewing thousands of empirical studies on the effect of added CO2 on plant crop yields, running from the 1950s, the studies done in the 1950s all the way to the present, concluded that simply because of more CO2 in the atmosphere, from 1960 to 2012, Global crop yields were about $3.2 trillion higher than they otherwise would have been. And if you project where CO2 is going on to 2050, we will expect another $9.3 trillion worth of crop yields. Who benefits the most from that?
Mankind.
Mankind generally? Who among mankind?
Poor people.
Poor people. Exactly. Because the poor spend a much higher percentage of their income on food than do the rest of us. And as crop yields rise, that means that the quantity of food available relative to the demand for that food rises, which forces the price downward. So food becomes more affordable for the poor because we're adding CO2 to the atmosphere. That, I think, is a pretty good thing. Now, this chart here shows us the areas where plant growth has increased in extent, range, or in density. And all the colors from here up are areas where the plant growth has increased. These colors and down are areas where they have decreased. What you can see very clearly here is the areas where plant growth has increased far outweigh the areas in which it has decreased. This shows from 1992 to 2012, but the same thing was going on for decades before that and has been going on since then as well. The sole reason for this is added CO2 in the atmosphere. This, by the way, is based on information generated by my good friend Dr. Roy W. Spencer, who is a principal research scientist in climatology at the University of Alabama and a senior fellow of the Cornwall Alliance, a very strong Christian man. And he is in charge, along with his colleague Dr. John Christie of the University of Alabama, of NASA's satellite program that is the /1 best means of our detecting temperature around the globe, all altitudes, all latitudes, all longitudes, 24/7, 365. This is the best stuff there is. They are NASA award-winning scientists on this. And so what this shows us is that as we add CO2, we're actually greening the planet. Again, if I were an environmentalist, I would think that's pretty good news, all right? Now, what this means is that I think we've got a lot of benefits to chalk up to our use of fossil fuels and therefore our emissions of CO2. And if I'm going to be persuaded that we need to reduce our use of fossil fuels and therefore our emissions of CO2, I need to be shown that my doing so will give us a better balance of benefits to costs than our not doing so. And by the way, I want to make sure that you understand, when I say benefits and costs, I don't just mean corporate bottom lines in dollars. I mean human well-being. I mean human health and human longevity. Those are the things that I'm talking about because really those are the bottom line measure of environmental quality. The environment literally means surroundings. It comes from a French word meaning to turn around. Our environment is our surroundings, and it's not only forests and streams and mountains and oceans, it's also hospitals and schools and factories and cars and trucks and planes. All of those are part of the environment. And the bottom line measure of environmental quality is human health and longevity, because we are the pinnacle of God's creation. And our well-being is the most important measure of the quality of the environment in which we exist. Yes, it's very important that we also make sure that we have good, healthy forests and healthy streams and rivers and oceans, healthy everything around us. But the bottom line is human health and longevity, which, by the way, have been rising rapidly through time, mainly through industrialization, mainly driven by our use of fossil fuels. Nonetheless, again, we're being told that we need to stop doing this in order to prevent dangerous global warming. Well, do I believe in global warming? You bet I believe in global warming, and I believe in global cooling. And they happen cyclically over longer and shorter cycles, overlapping with each other. They're driven primarily by cycles in solar energy output, solar magnetic wind output, various ocean currents, volcanism, and a number of other factors as well. Natural factors, not at all driven by human activity. Do I believe in global warming? I sure do. In fact, I even think this is probably a reasonably credible trace of global average temperature change from 1880 to 2016. This comes from the National Oceanic and Atmospheric Administration, part of the US government, and every bar here represents a year of global average surface temperature, and it's the baseline here, the zero, represents the 20th century average temperature, all right? So down here is below average, up here is above average, and you can see that over that time, boy, there's a pretty dramatic increase in temperature, right? And notice the colors. Blue, that's nice and comfortable, calming color, right? Red, that's danger, right? Did you realize you're being psychologically manipulated here? What if we show exactly the same data without the alarming red color? That's the same numbers, but it doesn't look nearly so alarming, does it? So here's a lesson about making sure that you are not being manipulated psychologically by how data are presented. But there's another piece of manipulation going on here that's a little bit less quick to be noticed, and that is, look at the scale. At the bottom, minus 0.06, minus 0.6 degrees Celsius. That's 0.6 of a degree below the 20th century average. At the top, 1 degree Celsius, 1 degree above the 20th century average. That's not an awful lot. As a matter of fact, in most locations around the world, nighttime low to daytime high differs by 5, 10, 20, even 30 times that much. And the difference between winter low and summer high differs by, 20, 40, 60, even more times that much. And guess what? It doesn't cause disaster. Now, this is why my friend Dr. Richard Lindzen, who is Emeritus Professor of Atmospheric Science at MIT and one of the world's most renowned climate scientists, says, and he's using very technical scientific language here, but I'll explain it for you if somebody needs me to. He says the appropriate response to this is, so what? Anybody need explanation of that? That's the deal, right? So suppose that we show this information instead on a scale that reflects, well, actually a little less than normal variation from nighttime low to daytime high, but this does it. And here we're centering it on the 20th century global average temperature, which was 15 degrees Celsius, roughly, all right? Those are exactly the same numbers as those. Sure doesn't look as dramatic, does it? Doesn't look nearly so scary. Well, this is a much more honest way of displaying these data. We could even go a little more radical than that by displaying the data on the equivalent of the Kelvin scale and putting the temperature up where it is in degrees Kelvin and topping the scale at a little bit warmer than the warmest natural atmospheric temperatures that we have on Earth. Now, I actually mislabeled this next chart. I should have labeled it as degrees Celsius, but it starts at minus 273 degrees Celsius, which is the same as 0 Kelvin, goes up to 327 degrees Celsius, which is about 288 degrees Kelvin. At any rate, actually this is about 288 degrees Kelvin. That's the numbers. That's the same information as that. Okay? And then we can even compute the percentage on that Kelvin scale. The percentage, this less than 1.4 degrees Celsius increase in global average temperature from 1880 to the present figures out to an increase of 0.35% in global average surface temperature. Now, I have to tell you that even just simply thinking in terms of pretty common sense science, I have a hard time thinking that that minute a change is likely to cause catastrophe. But I have a theological reason for thinking that way as well. Genesis 1:31 says that after God had created everything, he looked at everything that he had made, and behold, it was very good. And Genesis 8:22 tells us that following the flood, God made a covenant with himself, and he said to himself, as long as heaven and earth endure, seed time and harvests, cold and heat, summer and winter, day and night will not cease. Now, in the Hebrew language there, that's actually a poetic device called merism, in which these opposites on the spectrums indicate, yeah, those and everything else too, everything in between. The point of the poetry there is God is promising that he will preserve, he will sustain all the cycles on which human life and other life on earth depend as long as heaven and earth endure. Now, I happen to believe that an infinitely wise God designed, an infinitely powerful God created, and an infinitely faithful God sustains the earth and its climate system. Can we do harm to it? Yes. Can we do harm to it by an extremely minute influence on it? I rather think not. In fact, I illustrate it often this way. Suppose that the architect who designed this building had made it so that if I leaned on this wall, all of the feedback mechanisms would multiply the stress of my 200 pounds. I have a really good cook for a wife. They would multiply the stress of my weight until it became equivalent to, say, 20,000 tons of TNT, and the whole building would collapse. Would we say that that architect was brilliant or stupid? I think it's pretty obvious, right? Well, we're being asked to think that an increase in global average temperature of, at this point, 0.35% is going to cause catastrophic harm to the Earth's climate system and to all of life on Earth. Not only that, but we're being asked that that increase in temperature is being caused by an increase in CO2 that is itself minute. Now, the folks who press this alarm won't present it to you as minute. They will point out that since the Industrial Revolution, we have increased CO2 content in the atmosphere from 280 parts per million to 407 parts per million today. That's about 43%. That's a big change, right? But a big change from what start? 280 parts per million is 28 thousandths of 1%. 407 parts per million is 40.7 thousandths of 1%. When we achieve a doubling of CO2, probably sometime late in this century, it will be 56 thousandths of 1%, 560 parts per million. CO2 will still constitute just a tiny fraction of a percent of the atmosphere. And you want me to believe that that change is going to cause catastrophe all over the world? I'm sorry. I find that contrary to common sense, but also as a Christian, I find it insulting to God, to the God who designed this earth. All right. Now, let's see here. The next question, though, is, well, is this warming that we have observed, right? Whether shown this way, this way, this way, or this way, is this warming that we have observed, is it really driven primarily by carbon dioxide? Does our addition of carbon dioxide into the atmosphere cause dangerously rapid, high magnitude global warming? Now, the alarmists will say, if you question this, you're obviously a science denier because this is basic physics. And it's true, it is basic physics, because carbon dioxide is what's called an infrared absorbing gas. As energy comes to us from the sun, it's in the light spectrum, and when it strikes the surface of the earth, it bounces back in the infrared, the heat spectrum. It's no longer seeable, now it's feelable, all right? And some molecules, especially water vapor, but also CO2, methane, ozone, a number of other molecules, absorb that heat and re-radiate it. So in other words, they intercept some of the heat on the way out to space, and they send some of it back down toward the surface of the Earth. And so basic physics tells us that as you add CO2 to the atmosphere, you will make the atmosphere near the surface of the Earth warmer than it otherwise would be. You'll also make the atmosphere very high, cooler than it otherwise would be, because you're intercepting some of the heat that was headed out there, all right? So that's basic physics. And in fact, we have a formula, the Stefan Boltzmann formula, for calculating the black body radiation that tells us that for a doubling of CO2 concentration in the atmosphere, you'll get about 1 to 1.2 degree increase in global average surface temperature just from that before any kinds of feedbacks begin to come into effect, right? Now, the real question is then, what about these feedbacks? But let me also, before I get to that, point out to you another thing about basic physics. Basic physics tells us that if you drop a rock and a feather at the same moment from the same altitude, they will hit the ground at the same moment. Unless they're in the air, in which case the rock plummets and the feather goes like this, right? And if it's windy, the feather might blow up into a tree and get stuck and never come down. So in other words, basic physics tells us next to nothing about what happens in the real world, because the real world is a very complicated place. And the climate system is probably the most complicated natural system we've ever studied, with the possible exception of the human brain and DNA. So what does happen in response to elevated CO2? Well, the computer models on which the UN Intergovernmental Panel on Climate Change depends, on average, predict that the rate at which we're adding CO2 to the atmosphere should have been generating 0.4 of a degree Celsius of warming every decade since the beginning of our ability to measure global temperature using satellites, which is 1979. This is the period about which we can have the best data, the best observations, right? But the observations by satellites, by weather balloons, and by what are called reanalyses, which gather together all kinds of data from all kinds of sources all around the world, homogenize them and make them, fit together, right? Those observations on average tell us that instead global average temperature has been increasing not by 0.4 of a degree, but by 0.2 of a degree over that period. In other words, the models predict twice as much warming as actually observed. Now here we come to the issue of whether we're doing real science or fake science. Real science is characterized this way, as Nobel Prize-winning physicist Richard Feynman pointed out in a very famous lecture, and you can look this up on YouTube and watch it. It's a lot of fun to see. Richard Feynman says, when we want to know how something works in the real world, we do it this way. First we guess, then we make predictions based on our guess of what we should observe in the real world if our guess is true. Then we make observations in the real world, in the laboratory or out in nature, and we compare the observations with our predictions. If the observations contradict our predictions, then our guess, which is our hypothesis or our theory or even what we thought was our law, our guess is wrong. And it doesn't matter how smart you are or how beautiful your guess is, and I will add, or how many people agree with your guess. You all hear that 97% of all scientists agree that we're causing dangerous global warming. Number one, that's false, factually, okay? But number two, even if it were true, it wouldn't matter, because consensus isn't a scientific value. Consensus is a political value. You want to know who won an election? Count votes. Want to know how much CO2 warms the atmosphere? You don't count votes. You do the hard physics, the hard empirical observation and measurements, and that's how you find out. So what the measurements tell us is that over this period, we've only seen half as much warming as the models tell us should have happened. Therefore, the models are wrong. If they're wrong, then they provide no rational basis for any predictions about future temperature, and therefore no rational basis for any policy dealing with our predictions about future temperature. But I haven't told you the whole story here. There's more to it. The models assume that every bit of that warming should have come from nothing but added CO2. They completely neglect whether some of that warming might have come from natural causes, like solar fluctuations, or volcanic fluctuations, or cycles in ocean currents, especially El Niño Southern Oscillation. Might those have contributed? Well, we certainly cannot know that they didn't, because we know that they did through all of geologic history before this. Why should we think they've stopped? But in fact, the best investigations of this over the last decade or so have increasingly come to the conclusion that, as a matter of fact, solar variability, volcanic variability, and ocean currents, especially El Nino Southern Oscillation, have indeed contributed very significantly to this warming. In fact, this study, published last fall and a second edition out this spring by my friends Dr. John Christie at University of Alabama, one of the world's foremost climate scientists, and Dr. Joe DeLeo, again, another fine climate scientist, one of the founders of the Weather Channel, and by the econometrician James Wallace, who is a specialist in comparing the data about temperature with data about solar variability, volcanic variability, and ocean cycle variability. This study concludes that once you have controlled for solar variability, volcanic variability, and most important, ocean current variability, especially El Nino Southern Oscillation, once you've controlled for those three, you have explained all of the observed warming. There is no other warming to be blamed on CO2. Now, don't misunderstand me. I'm not saying that adding CO2 does not warm the atmosphere. That's basic physics. The interesting question, the challenging question is how much? And studies like this and many others show us, empirical studies, show us that the answer to that is so little we can't detect it. It's not nothing, but it's so little we cannot detect it, and therefore it has zero impact on any ecological well-being or any human well-being. Nonetheless, we're still told that we have to do this, all right? We have to, reduce our use of fossil fuels. Now, I'm going to show you real quickly a couple of other evidences that CO2 is not the control knob on global average temperature. That 40.7 thousandths of a percent of the atmosphere doesn't control temperature. First, the correlation between CO2 increase, which is charted here, and temperature increase is not good, because the temperature increase, while you do have that over the whole period, right, is intermittent. There are these periods of stasis, periods of no change, or in fact even slight cooling in the midst of it. Smooth, intermittent, no correlation. Now, correlation doesn't prove causation, but absence of correlation proves lack of causation, all right? So that shows that CO2 isn't driving the warming. But another thing shows that the actual causal connection is the reverse. Carbon dioxide concentration in the atmosphere rises and falls in response to changes in temperature. We know that because, and I can't take the time to really get detailed on this, but if I could, you would be able to see it clearly. We know that because, first we know it because of the actual measurements, but then we ask why? Why is it that temperature changes before CO2? It's because the oceans sequester a great deal of CO2. And they change temperature, as does the atmosphere, but they change much more slowly than the atmosphere because they're much more massive. The first 30 feet of the oceans have the same pressure as the entire atmosphere has. So they change temperature very slowly. Now, as a liquid warms, it releases gases. As it cools, it sucks gases in. So as the ocean warms, very, very slowly compared with the atmosphere, it releases CO2. So you get a little warming in the atmosphere, you get warming slowly following that in the oceans, and therefore you get CO2 emissions from the oceans slowly following that. And what we know on the centuries time scale is that CO2 follows temperature on average from about 9 to 12 and a half months, depending on the altitude in the atmosphere that you're talking about. So the scientists who are claiming that CO2 drives temperature change in the atmosphere are committing a very important scientific blunder, technical term for which is putting the cart before the horse. All right? So CO2 isn't driving. Nonetheless, we're told that we need to diminish our use of fossil fuels, to diminish our emissions of CO2, to diminish global warming. And I want to know what we're giving up if we do that. Now,
Kelvin, just one thing, tell everybody where the IPCC measures the CO2.
Well, one of the most important measurement stations is on Mauna Loa in Hawaii, which is a volcano, which emits vast amounts of CO2, but emits them intermittently. All right, so that's part of the problem. There are other other problems with CO2 measurements. I said earlier that CO2 concentration before the Industrial Revolution was about 280 parts per million. Actually, that's kind of that's a round figure, and there are other estimates that run as much as 330 parts per million instead of 280. And I said that, yeah, right now it's about 407 parts per million. Yeah, but there are other estimates that could bring it down or even up from there. In all of these things, I want you to remember something. The precision claimed for most of these things by people on all sides is almost invariably far greater than we have any reasonable claim to. We're talking about global scales, and it's really hard to measure things on global scales. In fact, well, I'll do a little bit of a jump here. We're being asked to support the Paris Climate Agreement, right? Canada signed on, President Obama signed on for the United States. He didn't give it to the Senate because he knew that that would reject it. But 195 plus nations have signed on to the Paris Climate Agreement. Got a question for you. How much would we reduce global average temperature in the year 2100 by full implementation of the Paris Climate Agreement, according to the guys who support it? Huh? Sort of close. The answer is 0.17 degree Celsius, which is 0.3 degree Fahrenheit, 0.3 degree Fahrenheit. Now, according to the guys who support the Paris Agreement, to their assumptions of best case scenario, how much will it cost to implement that over the rest of this century? The answer is roughly $1 trillion per year. From 2030 to 2100, that's $70 trillion. And if the politicians muck things up, and they're usually pretty good at doing that, it could be double that. So we're talking $70 to $140 trillion to achieve 0.3 degree Fahrenheit of global average temperature reduction. That comes to $23.3 to $46.6 trillion per 0.1 degree Fahrenheit reduction in global average temperature. Nobody could detect that. Nobody could feel that. It would make no difference in any ecosystem or in any human well-being anywhere in the world. Do you think that's a bargain? I don't. Now, back to where I was here. What do we get from CO2, from fossil fuels and the energy that we get from them and from CO2 emissions? Well, one way to look at this is looking at various different measures of human well-being and graphing them in correlation with, or lack of correlation with, if it turns out that way, our use of fossil fuels and our emission of CO2. Now, emission of CO2 is a good proxy measure for our use of fossil fuels because that's where it comes from. So this chart graphs or charts child mortality, which is deaths before the 5th birthday per 1,000 children born, versus CO2 emissions per person. With these circles, every circle represents a country. The size of the circle represents its population, relative population, and the colors represent its GDP per capita. Yellow is high income, green is upper middle income, red is lower middle income, blue is low income, white is not categorized. What you see here is that in 1940, for the vast majority of the world's people, CO2 emissions cluster under 0.5 ton per capita, while child mortality rates cluster between 200 and 400 deaths per children born by age 5. That means 20 to 40% of all children die before their first birthday in 1940 all around the world. CO2 emissions per capita, GDP per capita, and child mortality rates correlate very clearly. The more CO2 emissions, the higher the GDP, and the lower the child mortality. Now, over time, what we want to see is child mortality rates declining. If that happens, these circles will shift to the left. We also want to see GDP per capita rising. If that happens, we'll have more yellow, more green, and more red, and less blue. Well, in 2009, this is what we get. The circles have shifted left. We've got more yellow, green, and red, far less blue. For the vast majority of the world's, and by the way, all right, I'll tell it this way. For the vast majority of the world's people, CO2 emissions cluster between 2 and 10 tons per capita, which is 4 to 40 times the 1940 levels, and child mortality rates cluster between 20 and 60 deaths by age 5 per 1,000 children born, which is about 1/20th to 1/3 the 1940 rates. Again, higher emissions, lower child mortality, and higher GDP clearly correlate. That's because energy enables us to produce food, clothing, shelter, healthcare, transportation, all the other things that make us healthier and live longer, that reduce death rates at any given age. We can also show the correlation between GDP per capita, measured here, and hydrocarbon fuel use, measured here, and going from 1875 to 2010, this is what it looks like. GDP per capita rises as hydrocarbon fuel use rises. And we're being asked to cut hydrocarbon fuel use back. Now, unless we can replace all the energy we get from that at the same or lower cost, when we do that, we will be pushing GDP per capita back down. So to reach 1970 CO2 emission levels, we're going to have to go back to roughly 1970 GDP per capita levels. To go back to, which is the long-term goal of the Paris Climate Agreement, 1900 levels of CO2 emission levels, we're going to have to go back to 1900 levels of GDP per capita. So instead of around $9,000 per capita, we're going to go down to under $1,000 per capita. Anybody really excited about doing that? I'm not. Well, I'm going to skip this one because my time is about out. I'm going to have to skip that one. Around the world, the poor desperately need to replace the primitive energy system that they use with the advanced energy system that we use, the modern one, all right? Here's how the primitive energy system works. The source of the energy is wood and dried dung. The conveyance method is the backs of women, primarily. The average sub-Saharan African woman spends about 6 to 8 hours a day doing nothing but gathering wood and dried dung, which are her primary cooking and heating fuels. 6 to 8 hours a day to do nothing but cook her food and heat her hut. And it's a hut, it's not a nice house, all right? And it's not great food either. And the smoke from that, the World Health Organization tells us, kills 2 to 4 million people a year and causes upper respiratory diseases and eye infections in hundreds of millions of other people per year for varying periods, from a few days to months at a time. And while they're sick that way, they can't work very well to lift themselves and their children out of poverty. Meanwhile, of course, these women who spend 6 to 8 hours a day gathering the wood and dried dung, that doesn't leave them very much time or much bodily energy to do other work to lift themselves and their children out of poverty. No wonder they stay poor. What they desperately need is a change to the modern energy system, in which vast amounts of power, of energy, come to them in the form of machine energy rather than animal energy or dung or dried wood, right? Dried dung or wood, come to them in the form of machine energy powered primarily by electricity generated by, well, nuclear would be nice, but there are some major technical and security problems with that. Hydro is wonderful, but there are geographic problems with that. There aren't great rivers for that in all parts of the world. So the primary source is going to be coal and natural gas for generating electricity and petroleum for vehicle transportation fuel. 87%, as I said earlier, of all the energy we use around the world right now comes from fossil fuels. They desperately need electricity. And the cheapest way for them to get not a little tiny bit of electricity to run a light bulb or two and maybe a tiny little refrigerator key to keep maybe some medicine and a tiny bit of food from spoiling. No, I mean the electricity so that they can have lights all over the house, not hut, and a nice refrigerator that keeps plenty of food from spoiling and keeps medicines from spoiling, and air conditioning and heating and factories that work with assembly line machines and all of these things. They need vast amounts of electricity that will never come to them through wind and solar. And it has to be abundant, it has to be reliable, and it has to be affordable. That's what they need to rise and stay out of poverty. And that is why I am involved in this controversy. If it were just a matter of scientific curiosity, I would never have paid attention. But the kinds of policies that are being promoted to fight global warming are policies that will, A, do zero in terms of any benefits measured by temperature. I've just pointed that out. But they would do enormous harm by trapping a couple of billion people in the world who do not have electricity in the poverty that comes from their not having electricity for generations to come, and pushing many people in developed countries back down into poverty by raising their energy rates, especially electricity, so high that they can no longer afford to heat their homes adequately to protect themselves from winter home, resulting in, for example, in Great Britain, an increase in excess premature winter deaths from an average of around 7,000 per year pre-2009 to an average of around 25,000 per year today. See, this is why I'm concerned. The second great commandment says, you shall love your neighbor as yourself. If I were one of those poor people or one of those vulnerable people on fixed low income in developed countries, I would want somebody to be standing between me and the policies that would keep me poor or push me back into poverty. So what do I want you to do? Well, I want you to communicate to your policymakers, your elected representatives at city and county and provincial and federal levels that you want out of all policies that mandate the reduction of the use of fossil fuels and their replacement with wind and solar, because you want the poor taken care of. And I want you to learn more about this, because you need to be able to communicate well why you want that. So I want you to come to the Cornwall Alliance website, cornwallalliance.org, and read the studies and articles that are there, and share them with your neighbors and friends. Take the URLs, put them into an email, and send them off to somebody. Visit us on Facebook, Cornwall Alliance for the Stewardship of Creation on Facebook. Like articles there, that'll get them read by 10 times as many people. But especially share articles there. That can get them read by thousands of times as many people. Visit us on YouTube. We have a series on YouTube called Greener on the Other Side, Climate Alarmism, Facts Not Fear. And we have a documentary, Where the Grass is Greener, Biblical Stewardship versus Climate Alarmism, a DVD. We actually started out with a bunch of those to sell on this tour, and we sold them all out before we got out of Ontario last week. Sorry about that, but they can be had from our website in the shop there. And also go to our blog for millennials called earthrisingblog.com, earthrisingblog.com. Lots of stuff to learn there. And last, please pray for us. We're a very tiny organization. We operate on a shoestring. We have 2.5 employees. That's it. The vast majority of our support comes from individuals, many of whom have known me for 20, 30, even 40 years. We need your support. We also suffer threats against us. I've suffered threats to my life. Dr. Spencer and his colleague, Dr. Christie, have suffered threats to their life. In fact, on Earth Day, a few Saturdays ago, somebody shot 7 bullets into the window and surrounding wall of the office space where Dr. Christie's office is. Something of a warning there. So pray for us, please, and if you feel led to do this, you can also support us by donations that you can give at our website. So thank you very much. John has some words now, and after that, we'll have question and answer time. There you go.
Yes, thank you, Dr. Weiss. I do have something to share about what he is up to and what he hopes to do. But I do think that now might be a really good time to just shake out the shoulders, stand up, maybe something you don't know, and take a moment to just explain why you came. So just take a moment to stretch out and admire my artwork, and go and do likewise, just for a minute or two.
you should keep your day job.
Yeah, yeah, yeah.
No, I think that's really cute. I really do. Yeah, it works really well.
That went well.
Okay, thank you.
This is very, very,
Yeah,
very.
very responsive audience. Yeah, I can see.
ambitious, I'm losing my tongue here, new mission, I'd love to chip in as well.
All right, so questions? Go back here.
I'd like to know, is anybody measuring the amount of CO2 that's potentially we're changing by these policies? Like these policies are made and these big sign on these big deals, but is there actually a measurable change in the amount that the world's actually producing?
I know that some attempts are being made to make such measurements. It's very difficult to be even tolerably confident of the precision of those measurements because so many things are done in areas where we just don't measure. We can't follow them all. So I wouldn't begin to try to say, exactly what's being found out there. I can say that, for example, in the United States, CO2 emissions have been reduced very significantly, and I won't quote numbers because I've forgotten them at the moment, but they've been reduced very significantly over about the last 10 years, largely because of the revolution in natural gas extraction, especially by the combination of hydraulic fracturing, which is not a new technology, it's been around since the 1940s, with horizontal drilling, which is a more recent technology, and the combination of those two has allowed us to extract natural gas from geologic formations from which we could not get it before. The result has been an enormous fall in the price of natural gas that has led to many, many coal-fired power plants switching from coal to natural gas. CO2 emissions from coal burning are much higher than from natural gas burning. So the U.S. has achieved a very significant reduction in CO2 emissions over the period when, as a matter of fact, the European Union, which constantly criticizes the U.S. for our emissions, has not achieved anything remotely near, though it has adopted more stringent policies. So adopting policies is often window dressing compared with actual performance. Now, I will add this one more thing. I am not saying that to boast about the United States' achievement in CO2 reductions, because I personally don't value CO2 emission reductions. I would love to see CO2 concentration in the atmosphere go up considerably more because it will result in more food for everybody, and it will not result in significant increase in global average temperature or any frequency or intensity of severe weather events, anything of that sort. So I don't see a danger in CO2 emissions, so I don't mind they're going up. But as a matter of fact, they've gone down, not because the U.S. has had a consistent policy of trying to push them down, but because the tremendous revolution in natural gas recovery has forced it. Okay? Over here?
The temperatures, as you're driving a car already, you notice when you're driving how it is flexible through the countryside when you drive. But how about the weather stations? They are more surrounded by urban buildings and that stuff.
Absolutely.
Does that affect the temperature also?
Yeah. Okay. There actually, I think there are really two different questions in what you're asking there. The first question is, does the heat generated in urban areas from air conditioners that remove heat from inside buildings and send it outside, from the fact that we have paved highways and whatnot that absorb heat and keep it from bouncing back out towards space as quickly as it otherwise would, therefore raising nighttime temperatures. Does urbanization raise global average temperature? And the answer to that is not to any magnitude that is detectable. You need to remember this. First, about 75% of the surface of the Earth is water, and we don't have cities on water yet. Second, of the total land mass of the Earth, under 2% is occupied by human settlements, from anything from little villages of a couple hundred people to cities of 15 million. Under 2% is human settlements. So it's a small fraction of 1% of the Earth's surface that is occupied by cities. And not only that, but that's just the surface, and the Earth's whole atmosphere is really, really high. okay? So the heat generated in cities is just simply insignificant compared with the total energy content of the whole climate system, which is not only the atmosphere, but also the oceans, the ice in the world, the top layers of the soil, all the vegetation and everything else. Now, the other question that's hidden in your question is this: does the location of temperature monitoring stations cause an artificial appearance of higher global average temperature than is legitimate? And the answer there is absolutely yes. One Canadian economist, good friend of mine, former senior fellow of the Cornwall Alliance for the Stewardship of Creation, until his students started getting blackballed because he was with us. And so he said, Cal, I have to ask you to take me off your list because I don't want to hurt my students by this. And I was happy to do that. It's sad that people do that kind of thing, but I understood his predicament. Anyway, Dr. Ross McKittrick of the University of Guelph teamed up with an American climate scientist, Patrick Michaels, and they did a very important study published in 2004 that actually quantified the difference between real global average surface temperature and what we were being told from surface station measurements of global average temperature because of the bias of those stations toward urban areas where temperatures are warmer than outside urban areas. Just to illustrate from one city, in Phoenix, in downtown Phoenix, in the middle of the night, the nighttime low will typically be about 12 degrees higher than it is in the rural area outside the city. So it's a really big difference. They concluded that roughly 50% of the apparent global warming from, I believe their start date was 1960 to 2003, I think, or maybe it was 2000. Their study was published in 2004. About 50% of the warming over that period could be attributed solely to the fact that so many of the temperature monitoring stations were in urban areas, right? So, contribution to actual global temperature, negligible. Contribution to the appearance of global warming, very significant. Okay? Another question? Yes, sir.
I have two questions. Do you know of anybody that's done any studies into the correlation between CO2 concentrations in the atmosphere and the increase in size of deserts?
Actually, yes, there are such studies, but the correlation is actually the opposite. As CO2 concentration has risen in the Earth's atmosphere, deserts are shrinking. That's very clearly the case, especially in the Sahara Desert. The vegetation line has been marching northward since fairly early in the 20th century because plants grow better in warmer and cooler temperatures and in wetter and drier soils. And so they're able to move into desert regions. And the very fact that the plants get there starts making those regions wetter as well, because those plants collect rainfall, and then they evapotranspire that out into the atmosphere, and so they keep the loss of humidity from happening as rapidly. So what we're seeing is a shrinkage of deserts as CO2 rises. Okay? Well, I'll go for a new person here first.
The green energy program, is that using less or more fuel like fossil fuel?
The green energy program.
Windmills.
And solar. Okay. So you're not referring to a specific named program called the Green Energy Program that perhaps I haven't heard of, but you're referring basically to the, as we go to wind and solar, are we using more or less fossil fuel? Well, the really interesting thing is this, that we are probably using more fossil fuels as we go to more wind and solar, and the reason for that is this. Our grid, to function properly at all, has to have massive amounts of energy that is absolutely uninterrupted, no fluctuations whatsoever, has to be very precise measurement all the time, right? But wind and solar are highly intermittent. You're guaranteed an average of 12 hours a day in which the sun is not shining wherever you are, right? And then, of course, clouds interfere as well, so that makes more time that it's not shining. Wind isn't always blowing, and sometimes it's blowing so hard that you have to stop the turbines or they'll explode. So wind is very intermittent. That means that you have to keep a backup supply of electricity being generated all the time that can replace those when the wind stops blowing or the sun stops shining or the cloud passes over the solar farm. You have to have backup supply going from nuclear or from hydro, but those are few and far between compared with coal and natural gas-fired electric generating plants. That backup generation is done at what's called spinning reserve. And spinning reserve is the least efficient way to run a power plant. My friends at the Institute for Energy Research put it this way: requiring us to have wind and solar powered electric generating plants is like requiring us to own two vehicles. One vehicle will run whenever you need it. Another vehicle will run when it feels like it. You have to drive that vehicle that runs when it feels like it, whenever it feels like it. But you have to keep the other vehicle running in your garage 24 hours a day to back up that other one. And not only that, it has to be placed on a vehicle treadmill that is at an incline, and it has to be running at a speed just below the speed at which it would automatically shift into a higher gear to become more efficient. In other words, you have to use that at its lowest efficiency, in which you get the least return of energy generated from the investment of coal or natural gas into it, and you also get the highest emission of real pollutants, fly ash, carbon monoxide, sulfur oxides, nitrous oxides, heavy metals, things like that. You get the highest emission of real pollutants from that running at spinning reserve. So you have to add to the cost of running your wind and solar the cost of running that backup. And the result is that an electric grid fed by wind and solar gets more and more expensive the more wind and solar you pour into it. And you probably wind up using more fossil fuels because you use them so inefficiently. So it's a pretty ironic situation, right? Now, Fred, I saw your hand up before, and okay.
It seems to me that when you look at all the people here and the crowds and the science community and everything else, it seems to be more of a mature group that has the doubting Thomases, I guess.
Yeah.
Of all this CO2 scare, whereas the younger crowd seems to be brainwashed, indoctrinated, whatever.
Yeah. Why is it that so many of the skeptics on this stuff are graybeards and so many of the movement activists are younger scientists? All right, that's a fascinating question, and I'm not going to deceive you. I'm going to let you know I asked Fred to ask that question. He was asking it of me before, where he was raising the issue, and I said, I want you to ask that in Q&A time because it's a great question. I have 5 minutes left. I'll make this part of that, and then I'll get back to you for your follow-up. All right. The answer is wonderfully complex, but let me try to summarize it this way. First of all, younger people, I think, tend to be a little more gullible than older people, and you have to not be real good at applying the Apostle Paul's admonition in 1 Thessalonians 5:21, test all things, hold fast what is good. That, by the way, should be recognized as the foundation of science. Right? Biblical, right? That and the fact that we believe biblically that a rational God created an orderly universe to be understood by rational creatures made in his image, okay? There's the foundation of science for you. But younger people tend to be a little more gullible than older people. They haven't seen as many, big scares come and go as older people have. And so I think that's part of the explanation. But another very important part of the explanation is that older people tend to be secure in their jobs or done with their jobs, and so they're not worried about losing promotions, losing grants for their research, losing tenure or not gaining tenure, etc., because they don't follow the party line. If you're a young scientist and you're questioning this stuff, you are pretty well guaranteed not to get grants for your research. You're pretty well guaranteed not to get tenure wherever you are. So that's a fairly serious issue, so you just shut up. Even if you don't get on the bandwagon, you shut up. But the third reason, the one that I find the most fascinating and ultimately the most important, is that the older scientists generally finished their PhDs before 1980. The younger scientists generally finished their PhDs after 1980. Now, why is that important? Because prior to 1980, the vast majority of your scientific training was dealing with real-world objects, either in the laboratory or out in the real world, physical stuff. You were dealing with that stuff. You were measuring it. You were watching it. You were constantly doing observations in the real world. Computer time, by which you could run models of how that world works, was very expensive. But from 1980 on, that computer time just became so inexpensive that increasingly the education of scientists happens on computers where they make models of the world, and then they figure out from those models how they think the real world works. And here's the really fascinating thing. For a lot of the climate scientists, they have lost the capacity psychologically to distinguish between the models and the real world. This was revealed, documented in a study by Mayanna Lawson called Seductive Simulations, published in a refereed journal of the Sociology of Science in, I think it was 2004. She, by the way, believes in dangerous man-made global warming. She is a post-normal scientist, meaning she's very sympathetic to the whole methodology behind the climate alarmist message, okay? She has every reason to support the credibility of these scientists. But she went and lived for several years at the National Center for Atmospheric Research in Boulder, Colorado, which is the location of the most sophisticated, most respected climate modeling group of scientists in the United States. And she studied not climate science, but climate scientists, particularly climate modelers. And the question she had going into this study was, do they maintain consciously the distinction between their models and the real world? So that when they say, if we add such and such an amount of CO2 to the atmosphere, the ocean does so and so, they know that what they mean by the ocean there is, my model of the ocean does so and so. And what she discovered was, they not only don't maintain that distinction, they essentially can't. And when she would ask them in interviews, are you keeping this distinction in mind, she would get nervous laughter and then acknowledgments that they were not. You know, we all know that many young people, especially young boys, have problems of living in virtual reality. They're involved in these computer-generated fake worlds, and they spend hours every day in them. And this has actually become a psychological problem. Psychiatrists and psychologists do therapy with these children to try to get them out of virtual reality into the real world. That's where a lot of the world's climate scientists are. They're stuck in virtual reality. They can't see the difference anymore between their models and the real world, which means they can't do the key to science, as Feynman described it. You make your guess, you make your predictions, and then you compare your predictions with observations. They think that the output of their climate models is evidence. It's not evidence. It's highly sophisticated hypothesis. Sophisticated, yes, but not evidence. It is to be tested against real-world observations, and they won't do it. And when they are shown that the real-world observations contradict the models, they consistently say there's something wrong with the real-world observations. Well, you know, that's not impossible. Sometimes we can make mistakes there, but it's a whole lot less likely than making mistakes in the modeling. Okay, I'll leave that one there, and you had a follow-up. Oh, wait a minute. All right, Murray. Since you've already asked one. Murray, yes.
Can you say a little bit about the exponential negative effect of increasing CO2?
Sure, you just said it. Okay, here's the deal. Carbon dioxide and all other infrared absorbing gases absorb infrared, that is heat, within particular bits of the spectrum, of the infrared spectrum. The first 100 parts per million of CO2 that you put into the atmosphere absorbs a lot of the infrared within those I'm blocking out on the proper term for it. Come on, what's the proper term? Fred, Murray? Bandwidth, thank you. The first 100 parts per million absorb a lot of the bandwidth that it can absorb. The second 100 parts per million is stuck absorbing heat from the same bandwidth, but there isn't that much left there to absorb. So it absorbs a little bit of that. The third 100 parts per million is stuck absorbing only what's left there, and it absorbs only part of that. So the absorption rate of CO2 and any other greenhouse gas is what's called logarithmic. On a graph, it will go like this. So as parts per million rise this way, okay, absorption of heat goes this way, and before long, you can add more and more and more and make no difference. The analogy is, if we put a coat of white paint on that window, we'd block a lot of sunlight coming through it, right? But there'd be some still coming. Put a second coat, same thickness of white paint on that window, and we'll block some of that sunlight that's still coming through. But that second coat will not block nearly so much sunlight as the first coat did, because there's not that much left to block. Put a third coat on, and it won't block as much as the second coat, right? That's the idea. So right now, CO2 is nearly at the saturation point of the bandwidths that it can absorb, and we're about at the point where we can add more CO2 as long as we want, and it will make no difference in temperature. All right. Last question is your follow-up, okay?
With regard to the water cycle, do you know of anybody studying the effects of the water cycle in regards to an increase in temperature in the atmosphere?
Well, yeah, those studies are being done. One thing that it's mostly on computers, mostly on models, almost entirely on models, as a matter of fact. The Intergovernmental Panel on Climate Change tells us very clearly that the computer models are in fact incapable of the fineness of detail to tell us where changes in global average surface temperature will lead to more or less precipitation, more or less rainfall, right? They also tell us, by the way, that it is impossible to tie global warming to any increase in the frequency or intensity of any kind of severe weather events, whether it's droughts or floods, hurricanes, tornadoes, heat waves, cold waves, etc. You cannot tie global warming to any of those, despite the fact that our newspapers are always telling us that this blizzard was made worse by global warming. You know, they don't even believe the people whom they look at as the gods of this stuff, okay? Now, there's a fairly good reason to think that globally, on a global scale, a warmer world is a wetter world, because you'll get more evaporation and therefore more precipitation. History, our study of the history of agriculture, the history of plant growth and so on in various locations around the world confirms that pretty strongly. Also, by the way, our observation of history tells us that droughts are far more frequently in a cooler world than in a warmer world. Far more frequent, yeah, and also far more widespread in a cooler world than a warmer world. Also, storminess increases in a cooler world rather than a warmer world, partly because as the world warms, most of the warming happens toward the poles rather than the equator, so the temperature difference between the equator and the poles is diminished, and it's the movement of air masses by a difference in temperature that is mainly responsible for the development of storms, right? But basically the answer is, in very general terms, A warmer world is a wetter world, and that's a good thing, because plants grow more. Cold causes deserts. Yeah, that's very clearly the case. Cold is much harder for human beings and all other living things to abide by. I mean, just think about, the diversity of life near the equator versus the diversity of life near the North Pole or the South Pole. It just isn't much there, right? Also, for instance, cold snaps kill 10 times as many people per day as heat waves do. People succumb to the stress of cold. During the medieval warm period, from roughly 950 AD to 1250 AD, you had a tremendous increase in human thriving. During the Little Ice Age, you had a diminishing of human thriving. The Little Ice Age was the period that included the bubonic plague. And that spread partly precisely because people's immune systems were so compromised by the cold that they couldn't fight the disease. Their bodies couldn't fight the disease. So, all right, I am very grateful to you for your attention. Thank you so much for coming tonight. Remember, communicate to your elected representatives. Pass this kind of information on to others. Don't be afraid to do that. And please, pray for Reformed perspective. Be generous in your support of Reformed perspective. They are bearing the entire cost of this tour, including for me, and I'm very grateful for that, so please be generous to them. And as you pray for them and for us, I'd also appreciate it if you would consider the possibility of supporting Cornwall Alliance as we operate on a shoestring. Thank you very much.